Alright, hello. Sorry I'm a little bit late. Traffic. And by traffic, I mean foot traffic. And by foot traffic, I mean walking back to my room. Anyway, this is day 59 of studying compilers every day until I land a compiler role. I'm too early for the elite code actually, so we don't have that. But, things I still want to do, I guess like the plan for today is just fixing up some stuff here and there with the stuff that I did last time. So last time I started doing the parser rewrite to accept like real expressions instead of just like a narrow subset of them. Or I guess like the phrase I'm looking for here is I guess like compound expressions, something that's just not simple. So yeah, this time we're gonna keep going at that. We started the parser last time, let's hopefully get it finished by today. Oh, I just leaked everything, god damn it. No keys, okay, perfect. Okay, we're fine, everything is fine. Where am I? Okay. So yeah, let's get started with this. Where am I? Let's go Yante. Okay, here we go. Okay, so yeah, we started this whole slush pile down here. Yeah, we're gonna work with that this time around, hopefully. So yeah. I think what I'm gonna do is I'm gonna take each of these actions and then we're gonna, I guess each of these parsing things, yeah, so like call here, or like the unary operators, or like multiply, divide, so on and so forth. And we're gonna give them actions, I guess. Yeah. Is that parser lib? Yes, this is pegtool, which is parsing expression grammar template library, I think. So I guess peg template library. Those are fine. So we can do expr actions. Okay. We're gonna do a lot of copying, I fear. Instead of number here, this is, let's just work top down here. We could start with call. And then instead of using parse tokens here, we're gonna use parsed exprs. This might be a little bit annoying, actually. Yeah, because we can't really just keep parse tokens, to be honest, actually. We might have to make a special action for, like, level 1, just to make a thing, I guess. Okay. Or maybe I could just put all of the tokens onto there. Is there an instance where I wouldn't do that? Yes, actually. Function names. So I can't do that safely, I think. Let's see. So I guess what does the structure look like again? Yeah, I guess if we end up with value here, right, is that what we're looking for? Yeah, I guess if we parse value, I think that might be what we're looking for. I could probably put value in here even, and that would make sense. Yeah, I actually quite like that structure more. Let's do it that way. Yeah, okay. This makes more sense in my head at least. Okay, so let's get this started. For call, we just want to pop the backmost. So we want parse tokens. Oh wait, no. We have helpers for this now. Pop identifier, I guess. Yeah. We can do that. Yeah, okay. So we pop identifier, and we need to, what do I even do from here? Let me figure out food real quick, sorry. Okay. Sorry. Okay. So we get the identifier and then we need to make the thing, right? So that lives in expr. Call expr. This is actually callie. So then we need to import expr, right? Oh, we already do. Nice. So then first expr is we want to push back. Alright, we need to make it. Expr. I guess we can do it this way. Make unique. This is it's a call expr. I don't know why it took me so long to think of that. That's really funny. And this just takes the callie. So stood, move, callie. Right? No matching template. That's a unique putter to an atom. Oh, literal identifier. Whoops. Yeah, that's not intended. There we go. So now that should fix up, right? Private constructor. Oh my god, I forgot to put a public on these. Whoops. Oops, let's fix that. If I can spell. Okay, I think that's all of them. Okay. We're just gonna commit that real quick. Okay, so now we can push back the move. Yeah, like, and that should be good to go. What was the philosophy in doing that instead of handmade? Honestly, I didn't really care about the parser too much. That's kind of the only reason. And it feels like I think a hand-rolled parser would have just been more of a mess to maintain, I think. But also, like, maybe I'll end up implementing it by hand again at some point anyway, just because, like, it might be a fun challenge. But for now, Peg is relatively easy. It lets me save a little bit of time. You can call it a day. How good are your error messages? It just doesn't fire, I guess, if it doesn't parse something. I should probably figure that out, to be honest. So, yeah. How good are they? They are non-existent, I think. Yeah. For now, at least I'm just assuming correct input. So, eh. Okay, let's steal this. Actually, let me look this up. I'm kind of curious. Oh god. It definitely has docs somewhere. Doc. Errors. Yeah, I guess if it, or at least the way I have it set up here, the way I have it set up here, I don't think it ever can throw in a parsing error. Or actually, wait. There's probably a way for me to do it now that I think about it. There should be like a pectoral must somewhere. Yeah. Do your LLVM baseline on GitHub use a handmade parser? Yeah, that one. If you're talking about the kaleidoscope stuff, that followed LLVM's tutorial, which was a hand-rolled parser. What I got from that was it's just low-key kind of annoying, and it's not particularly interesting to build, so I figured it would be somewhat interesting to skip a lot of the work. Pectoral must. Damn it, okay. Let's... Should be like a must somewhere. Or at least there should be a doc for somewhere. How do I search this in any meaningful way? Must? Okay. Entry point is a... Oh, wait, I see. This should be... Pectoral plus... Actually, no. This is fine. Yeah, I don't know. I'll figure out errors eventually when I want to make this like human usable. Yeah, parsers have never been a top priority for me, at least, but that's also a little bit of cope. So I mean, yeah. Okay. So this we want to replace with. Let's figure out harpoon for this real quick. Let's add that. And then let's go back to here. Okay. Low-key after learning assembly, everything just clicked from ASCII to raw binary and opcodes. Yeah, that makes sense. That sounds about right to me. I feel like it's a lot easier to reason about everything when you know assembly because everything is kind of a C clone in disguise, and C is an assembly clone in disguise. So, yeah, I think that makes a lot of sense to me at least. Okay, we need a rule for value. So value is we have pop atom. So this should be just a AST, I think I called it terminal expert, yeah. Value. Okay, perfect. Okay, so those are made. Now we can start working up the tree. We can start here now. Stack? Yeah, I mean, it is a stack. Okay, let's do more stealing. Also, I'm using a vector for a stack because I don't know why you would use a stack for a stack. Everything is wrapper assembly? Yeah. I mean, you're not wrong with that one, to be honest. I should make a pop expert, probably. Yeah, that would be smart. We have tokens, experts, and scopes. These get the tokens. Need footer to atom, or not atom, expert. Generically expert. Assembly is a wrapper around electrified rocks. I love that sentiment. That makes me strangely happy for some reason. And I can't really figure out why. So we wanna... Oh, we need to move this, right? We want to move that, and then we want to parse expers, pop back, turn exper. Electrified rocks are a wrapper of atoms and electrons. Yeah. I really like this sort of reductionist sort of reasoning. It just reads really funnily to me. I love it. Yeah, I mean, what is more human than taking rocks and doing things with rocks? Let's be real. Unary. So auto expert is pop expert. And so call expert, we want unary op expert. Why didn't I just name it unary expert? Because, like, yes, the op is kind of implied, I guess. That's fine. Oh, that's good for a night gamer. What op do I use here? Unary op. Oh wait, no. Unary op. Is it just unary? Oh, plus. Clutch. Okay, nice. Fancy's rock. Let's do some math. Yeah, I mean, is that not an accurate description of just computer science as a whole? Like, I think that's a pretty valid sentiment to have. Yeah, let's yank that. Change this to minus. Yeah. And we can change this to minus. Okay. So that's the expert 2 level. We need expert 3 now. So now we get multiply and divide, which is fun. Why don't I just steal this again? This is multiply left. Oh wait, because this is a stack, we have to pop the right first because we have to pop in reverse push order. So we have right, we have left, and then we want expert, I guess. Let's make these names a little more consistent, actually. We can do back or bow, I guess. Back. Let's do back. Okay, and then this is expert. Yeah. okay, that's more correct. Oh, that would have caused a crazy bug, actually. It just occurred to me. Okay. And this is back. Back. Okay. Should take a break on day 60? I've gotten a couple of breaks already in, so I don't see a reason to slow down at least. Like, I had a break for hackathon, I had a break for like travel day, so it was like fine already, I think. Oh wait, I can't type. Okay. Oh wait, this is the wrong one. Mole. Oh, we don't have divide yet. Oh fuck, okay. Okay, let's get rid of that. Okay. Opinion on RAI? I think it's fine. I don't understand, or like I haven't thought about it enough to have a bad opinion on it, at least. Python is garbage for ML, C, C++, and Rust much better? Well, I mean, like, on one hand, like, yes. On the other hand, the big ML libraries are basically C, C++, and Rust anyway, so like, I think it's fine at least. I mean, yeah. Yeah, unfortunately that's a little bit uninteresting. Okay, so we have multiply now, we just need add, subtract, and then bitwise and I think we're good. Yeah, okay. Okay, let's do all of this again. Y'all ready to watch me write the same thing 3 different times? Okay, let's take this, let's make this add. Instead of a mul here, this is a add. This is a subtract. This is a sub. Speaking of subs, sub to my channel if you haven't. That would be rather great for me, at least. Python started with NumPy, so TensorFlow and PyTorch liked it, so they built themselves off it. Yeah, I mean, even still though, I think the raw backend is also just straight up C and C++ at this point, right? You'd have to fact check me on that though. Yeah, okay. Okay, so that's all of those done now. We can start cleaning up our mess now, I think. Expr, this is just a... We need to add new things to the AST now, I think, right? Yeah, we need to add a straight up Expr instruction, I think. We need to change a lot of things here, actually, now that I think about it. Let's add this first. Yeah, let's change the instructions here now because we have a lot more interesting stuff to work with. Yeah, the big thing is we don't have straight up values anymore here, so this will be a little bit interesting now. Networking C is pretty fun. Yeah, I haven't worked with C networking yet. I should probably just have like a month or 2 where I just do networking stuff. I think that would be maybe an interesting like side series, but I just don't have the time for that right now. But yeah, that would definitely be something I try. I think it'd be funny just to like re-implement a WebSocket from scratch. I should just review networking, period. I know very little about it, to be honest. These are fine, this is fine. We're gonna need to change a lot of things. Okay, let's see. What do we do here? I think how I'm going to structure the AST from here is, so if you remember back from like when I was like architecting this stuff initially, so we have the AST here, and then we have HR, which is like a desugared AST. So I'm thinking we also just like handle all of the expression order stuff, or like we I guess like reduce the compound expressions down to just like their raw orderings, further down, I guess, between AST and HR. I think that might be the play. Because beyond that, I think this doesn't really do a lot in terms of lowering. Like we resolve scopes and like we simplify some things, but that's about it. What are the differences between HR and MR? A lot, to be honest. HR is more akin to just a desugared AST than like a proper IR, I think. Yeah, that's where the conversion between AST and HR is where I handled, I think it is just descoping and then like simplifying some expressions down. So then cogen down to the cogen? I guess lowering down to MIR proper is less miserable. And I need to handle less cases. But unfortunately everything is still very coupled, so I will have to deal with the consequences of that. Yeah, with all that out of the way, I think it's time I start rewriting some of this. I think I could kind of match this pile 1-to-1, because I think that's what I used to do anyway. I think I could go top-down order here. We need a class instruction expr. It's just a straight-up expression. So like, this also counts as just a function call, but like, we get really funny expressions like, what's it called? we can like write a program that's through just one semicolon. I think I did that. Oh, I didn't do that here. So we just have like one. This is a valid program. It's really funny that this is a valid program, but yeah. There's some rather insane stuff we can do. Anyway, this is an instruction. Yeah, let's kill that real quick. Let's make constructor. The state stays stood unique. Putter to expr, I guess. And then can steal that. Oh, I need to include expr. AST expr. Okay, so we have expressions now. We're gonna need to change a lot of things to also take expressions now, but yeah, that is kind of inevitable. Yeah, let's do that. I think, do we even need a visitor for expr toString? I think we might. Yeah, for like dynamic dispatch related reasons. We can make an expr visitor, I guess, and that will be interesting. We will use it exactly once. Actually, no, we will use it twice. There are two good instances that we could use it. Anyway, do that. This is a reference. Get expr. Okay, so that's instruction expr fixed now. I'm gonna try something really stupid here. I'm gonna make a divider here so I know where I am. I promise this is like not a gigadweeb play, but it might end up turning out to be a gigadweeb play. Declaration we don't need to change. Assign value I think we do need to change, because we changed what it is at least. Okay, this is just instruction, declaration, assign. This doesn't take a value anymore. Instead, this takes an expr. So we have a type, we have a variable, and we have an expr. So we have type, we have a variable. Those two are the same. This is not value anymore. This is a expr. Expr. Yeah, that's fine. This needs to change. Okay. Assign value, I think we don't really have a concrete or like an explicit value notion in instructions anymore. At least it's all expressions now, which is both nice and terrifying, at least. Yeah, so it's an expr. Variable is fine. So then expr. Yeah, that makes sense. Oh, we need to steal this. Okay. This doesn't exist anymore, I think, because that falls under assign, I think. Return we still have. Call we don't have anymore because that is just an expr or an expr assign. That goes down here. We changed. Oh right, I forgot to change this actually. This is an expr now. Expr. This is an expr. Yeah, okay. That branch control flow structures take an expr. Okay. It's an expr now, but we can be a little bit conservative with what we changed, I think. That's fine. Oh, that's not an atom anymore. This is an expr. I'm gonna undo a lot of this for a second because it might be less confusing if I just... Okay, that bar was a gigadweeb thing. That was stupid. Why did I do that? Yeah. I don't want to name these expr actually. I think it's still fair to call them value, I think, right? Right? Nah, we're gonna call it expr. I'm gonna redo all of the undid work. Or at least... Cause like expr is kind of vague, to be honest. So even just like... Here, I mean, it makes sense because this is just straight up an expr, but like... This one's fine. I guess we should call it a value. Yeah, okay. I'm a little bit happier with that one. I think that's a good balance. Okay, that's fine. Variable value. Return. This still is a value. Expr. Okay. Return's fine. See, like here, for instance, is an example where if I called it expr, it'd be very ambiguous. then expr, expr, expr. Okay. Yeah, we need to change this pile now. We have that now. It's just an assign. This doesn't exist anymore. These two don't exist anymore. Okay. What's wrong now? We don't use operator. That makes sense. Yeah, everything is now an expr. Just double check. We need an item there. That makes sense. We need an item there. That makes sense. Yeah, we need an item there as well. That makes complete sense. Okay, and those are the only items left. Yeah. Those are. That one makes sense. 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 Okay. Alright, so we have expressions now. Oh boy, we need to fix this now. Alright. Fuck, man. Oh boy. Cleanup time. Okay. Scope is fine. Need instruction expert here. Yeah, let's deal with that. Let's do expr stood move expr. Okay. Just install NeoVim after recent tutorials. Assuming I know how to install plugins. Found one guy that explains like timing queue. Good stuff. Yeah, hopefully you stick with it and I guess just have a good NeoVim time, I guess. I will say it's really easy to just get to the point where you really enjoy like messing around with your config because it's just like nice once you have the power, and then it's like low-key dangerous because all of a sudden you just don't have time anymore. Okay. So that's expert implemented. Declaration doesn't need to change. Declaration assign has a different name now. With that now, this is an expert. We don't have that anymore. Don't have that anymore. This is actually not that bad of a refactor, to be honest. Oh, and this is less ugly now because we can put that in one line now. Okay. Okay. Next is instruction assign, but not value anymore. This is an expr. This is fine. There's a reason why most, if not all, ML models are built with Python. Strips away all the low-level details about an application while keeping only what the app needs to do. That sounds reasonable. I think it's disingenuous to say that it's like Python though, because all the stuff in the back at least is optimized C and C++ code to my knowledge. But like from a usability standpoint, Python definitely makes sense as like the interface at least. Oh yeah, because value doesn't exist anymore. Okay, next one is this doesn't exist anymore. Thank goodness. this is just expr now. Yeah, return was pretty clean, at least it feels like. Okay, now we have if, while, and we just have if and while, I guess. Nice. Maybe I should just add like a has f branch as well. That might clean up some of the code actually. Yeah, let's do that while we're at it. Break happening at day 69? We'll see. No guarantees on any of that. Okay, call assign doesn't exist anymore. This is an expr. The rest of this is fine. We should have a cool instruction if has f branch. Because now I don't need to like explicitly do this. I can kind of just like hide it behind something that looks a little bit less awful. Can do a little bit more object-oriented style programming, which will very quickly devolve anyway. So I guess what's the point? But also, I don't know. Return f branch. Yeah, I mean. So if it's not null putter, yeah, okay. Yeah, I mean, I would at least enjoy making my code something that I can like look at again in the future. So I think that's maybe worth it. Yeah. Yeah, I would very much like to be able to read this again. Update instruction. Okay. Let me make this more verbose. New expr. Okay. So with all of this done now, we can finally go back to where we were in the parser. Oh, there's problems in AST? Uh-oh. Oh no. Oh, I forgot about that. Okay. Yeah, we need to fix the toString visitor because again, this doesn't really exist the way we want it to anymore. We don't have that anymore, we don't have that anymore. Okay. So this also propagates down here, unfortunately. We also have another instruction that I'm missing. Yeah, okay. What's wrong here? Huh? Oh, wait, I forgot to add it down here as well. Oh, I just pranked myself. Oh, Jesus, I can't spell. Okay. Okay, fix that. Now we can go back up here. This is good stuff. We shouldn't need this, to be honest. I think. Maybe we do. I don't know. I don't care enough. Most of this is still fine. We just need to figure this stuff out. Have you tried Rust before? Yes. One of my current projects is in Rust. One of my previous projects is in Rust. I quite like the language. I think when I used it before, I didn't fully appreciate it just because I was like, my C++ fundamentals were very weak. But I think after having used C++ for a while, it's a lot easier to appreciate a lot of its design decisions. And I'm quite happy about that, at least. Let's visit instruction expr, putter I. Yeah. This also reminds me, I need to figure out expression. Yeah, let's make a visitor for this as well. Yeah, I think we should add a visitor in here. Yeah, we can do that. At the beginning I rejected Rust, but after looking at how safe it is, I have mixed feelings. Yeah. I think even just like, it is literally just like, I think if you understand the borrow checker and you understand like what everything actually does, like you can, I think it's very possible to go back to writing C++ code and even just be like, oh yeah, this like actually makes sense. I understand how to write less bad code now. It's like opening a third eye, you know. You find new bad code smells that like you never knew existed. At least. That's my take though. Okay. So we want void visit or visit accept. I need to forward declare. Expert visitor. Yeah, I can forward declare that. How did I do that down here? Just yeah. Or wait, where's accept? Visitor. That's very verbose. I should have just done V. What am I doing? I might just have a big formatting day as well in the future. Let's see, putter. Let's do that. Yeah, okay. Got more visitors. After trying to avoid new and delete in C++ after coming back from Rust? Yeah, exactly. Yeah. I think like in addition, just like being able to reason about things through the lens of like Rust's opt-in choices as well is really nice. Where am I? Yeah, we can, okay, so yeah, that makes sense on how I implement this. So I'm gonna visit expr E, right? Oh, it should be virtual, okay. Okay. So we want terminal expr call expr. Then we want unary op expr binary op expr. Okay. Okay. I think that's all we need for this. Let me just compare it to my instructions. Yeah, looks good to me. Right, so with that, we can, I guess, extend it here. Oh, fuck. Yeah, this should extend expert visitor. Right? Yeah, that should be public. we're just gonna... We're just gonna do this by hand because I'm lazy. I'm so lazy I will inconvenience myself. Okay, perfect. We level formatter as well. Okay. So what do I even do here? This makes a bit of a mess, huh? This all lives in here though, luckily. Yeah, so we want... It's on a... I get expert accept. Right? Oh, wait, no. What does this return? Yeah. Oh, get expert get? Visit. Oh, yeah, this is how we do it. Okay. And then we... This is gonna be pretty funny. So then we just res. So that sets the result. And then we want to just add. How do I even do this? Res equals, I guess, like string instruction res, or iRes, I guess. We can do that. We can visit iRes. Res equals I. Wait. How do I even do this actually? Okay, so we visit that, then do we want that to just be additive or do we want it to be separate altogether? It should probably overwrite, I think. Alright, no, it should be... okay. Yeah, that should be additive, I think. That would be the easiest way to handle it. Yeah, so we can visit that, and then... Right? Is everything else additive? Should be visit I, right? Get. Yeah, that's additive at least, right? Alright. No, that overwrites. Okay, so we should probably be consistent with that then, right? Yeah, so we want prefix, then... okay, so we have that, we want to visit, and then iRes, we want to add get result plus semicolon. So we can set res now to iRes. Okay, so that's how we want to handle that, at least. Okay, so we can kind of do something similar here, I think. Or this one is fine. This one, this doesn't exist anymore. This is now a mess though. Actually, we don't even need this here. Still in HR to MIR? Not even. This is all just like toString for AST right now here. Expert equals get results. Wait, why am I using get result here? Res actually. That's just a copy, I think, right? So that's fine. So we want prefix plus res plus semicolon. All right. Wait, what am I doing? I'm like trying too hard to make this code pretty. We can just do this. This is fine. This we need to fix. Variable equals, and then alright, we wanna visit I get value dot get. Yeah, and then this one we can do res here, which is kind of funny. Okay. Oh, come on. Value we don't need anymore. We can just seal that, I think. Don't have a notion of value there anymore. It's just an assign. This is now res. We don't need this anymore because that doesn't exist anymore. And this, I think, oh, right, we can't do this anymore. Need to steal this again. This is res again. Yeah, these 2-line ones are pretty funny to me. This doesn't exist anymore. This needs to be a different thing. This one we do need a temporary for, so we can't be clean with this, unfortunately. Okay, so we want string, or we can just change this, right? We can visit I get cond get res. Okay, perfect. Okay, we have that. I think this overwrites, which is nice, at least. Right? Does it overwrite? It looks like scope overwrites, which is helpful. Yeah, okay. Scope definitely overwrites. We can change this now to I has F branch. Okay. What the fuck is happening here? If T branch is not a null pointer, then what? Oh, if it's a scope, I see. Okay, yeah. We have to handle it differently. Okay, we can steal this stuff at least. Okay, and then we have to. Why is this still if res? While res. While res. Okay. Alright, that's all cleaned up. I think, yeah, we got expert as well. So we just need to get these visitors now, which is scary to me. Okay, I'm gonna go to the bathroom real quick. Yeah, don't burn down the house while I'm away. Alright, I'm back. Sorry about that. Just in time for music swap, I guess. Okay. So we just finished updating the two-string visitors for all the instructions proper. Now we need to actually do it for the expressions, which is a little bit scary, but I'm sure it'll be fine. Yeah, so let's paste these in here. let's void. We can do visit, and then we can fighting one-eyed Kirby, override. It should have a closing parenthesis on it. Let's replace that with we can even be more greedy with this, I think. Void, and then we can do this now. And then semicolon, I think? Or override semicolon. Yes, we can replace that with void to string visitor. No, 1 space, and then braces. There we go. Perfect. Clean little macro. Yeah, okay. Let's swap these windows real quick so I can read like a human. Okay. Okay, so we want res to equal I think we had a unknown expression or unknown instruction thing here, yeah. Yeah. Yeah, okay. I think that's a good catch-all to have. Okay, let's go back to here. Right, terminal expr, we want to, oh boy. How do I even do this? How did I do toString before for the atoms, at least? Yeah, let's check this out real quick. Because I'm too lazy to pull it up in a normal way, so we will do it this way. Okay. We can just get value to string, it looks like, which is very helpful. We do need the symbol table, but that's fine. Okay, so we want res is now e. Oh, we need actual methods on these now. Yeah, so we want get atom. Right. Unique footer atom get atom. Right. Yeah. Okay. We need the same here. Or get atom actually. Right? Or no, this is fine. This is fine because we don't have another place we have Kali. So this, I thought there was ambiguity there. There was not. Yeah. So those are the only ones that makes sense for. This one is a. This should also be a reference. That should be a reference. Everything should be a reference. Get value. And then unary op. Get op. Okay, so we should do it here as well. But this is a binary op. this is left, and we want get right. Get right, like the player, like the CS player. Anyway, little tangent aside. I'll implement those in a second. Let me get these done first. So we want E get atom to string, and we give it symbol table. Yeah, okay. Ref to symbol table? Putter, okay. Yeah, okay, that's how I did it everywhere else. Okay, so we want that, and then we wanna add a, yeah, I think that's it actually, yeah, that makes sense. So we want res equals E get callee to string, give it the symbol table, and we want to add a, and just add this for now. To do function params. This is just a running joke at this point. These are the wrong braces as well. Oops. Okay. Yeah, that makes sense. Okay, unary op. So we want string op is E get op, or even to string E get op. Yeah, okay. And then need that here as well. Okay, then we want to say const, I think, right? I don't know why I stopped doing this, to be honest. We want to visit E get value get, and then res is op plus, yeah, because there's, yeah, this just goes in front of the thing, so that's fine. Right, is there an instance where it's not? I guess not, so this is fine. So we can just do that plus res. Yeah, okay. Okay, so we want, it should be left. We want res. Oh my god, what was I? Where are my typography skills? Okay, this is get right. Okay, so then res is now, we want left space, and then we want op, and then another space, and then right. Okay. So we have that. Now we just need to implement all of the stuff we added, which shouldn't be that hard, I think, I hope. Also, it just occurred to me, we can't really test everything. Because we need to go all the way down the chain before we can test things. We want terminal, expert, get atom. Or this is stood, unique, putter, atom. Okay. These need accept as well. Alright, is this how we do this? Oh, wait, yeah. Yeah, so we should be calling accept in here then, right? Yeah, okay. So I definitely did that wrong. I'll remember to fix that. Or actually, I'm here now. Let's fix that. So we want I accept this. Yeah, okay. So we want I get expr accept. These should have accept on them, yeah. What's wrong here? Oh, whoops. Yeah, okay. Oh, this is virtual? Right, how did I do this before? Virtual void accept equal, okay, so we need to default it as well. What else did I need in here? I need a virtual destructor as well. Okay. What's wrong now? Oh, these need to be public. That's what I missed. Okay, perfect. All that's still fine now. That's fine. I get value. We want to accept this. We can just steal this line, paste it over and over. Yeah, we can do that again even. Wow. I wanna... Okay, that's fine. This is right, left. Okay. Okay. I think that's all of that cleaned up now. We can go back to what we were working on, which is implementing all this stuff. Okay. So we got get atom, I think. Right? Yeah. So now we need get Kali. And then we need this. That. What's wrong? Oh, it needs to be a reference. Right? Oh, identifier. There we go. First try. Okay. Yeah, that's all that's for that one. Okay. This one is expert. Op expert. Get value. Unary op expert. Okay. We also need get op. Okay. Yeah, that's all for that one. Just need that twice, sort of. Left. Or wait, right. Wait a second. This is binary op. I can't type. Okay. We can do more boilerplate. Yeah, okay. That's fine, that's fine. We need get op still. That's all we're missing. So we can do binary op expert, get op, return op. Okay. I think that's everything then. It should all be implemented. I have no way of testing if it's implemented correctly, but it's all there at least. Okay. Alright, now we get to clean this mess up, which I really don't want to clean up right now, to be honest. Yeah. So we need to make a bunch of temporary variables as well, is the other problem, and that will not be fun. How do we want to make temporary variables? I guess we could just do like underscores. Underscore and then like some number. I think that's the easiest way to do it, but yeah. There might be a chance something breaks from that, so we'll have to check at least every time we make a new one. Okay. I think I'll save that for next time though. I'm quite tired. It's a Friday, damn it. What did I change in here? About instruction, expert, oops. Okay. Finish, expert, getters, and then st. Okay. Alright, I think that's a pretty damn good place to end today. Yeah, thank you all so much for showing up to stream. Even if today's a little bit shorter, I promise next time will be a little bit more involved because I will have to get even more into the weeds. Make sure you like the stream if you haven't and sub to my channel. Both of those really help out with the algorithm and help get my content out to more people. While you're down there, make sure you join the Discord. It's the best place to get notified when I go live, and yeah, best place to get notified when I go live and chat with me and the broader community outside of stream hours. And yeah, make sure you add me on GitHub and connect with me on LinkedIn to stay up to date with what I'm doing. And yeah, I think that's about it. Thank you all for being here. I'm gonna get food. I'm quite hungry. Yeah, take care, y'all. Take it easy and have a wonderful rest of your day.